Assalamualaikum and good day to everyone. So now we're going to continue with single degree of freedom system chapter, and we're going to look on some examples, and we're going to try to solve the simple example here. So let's look at example 1. Okay, so the mass of the system is given as 49.2 gram here, and the spring constant is given as 857.8 Newton meter. So the question asks us, calculate the natural frequency in Hertz. Okay, we know that natural frequency is omega n, but the unit of omega n is radian per second. The question didn't ask us in radian per second, but instead it asks us what is the natural frequency in Hertz. So what the question asks is to find F. F is in Hertz and omega n is in radian per second. So it asks us to find the natural frequency in Hertz and also the period of the system. So how do we want to find the natural frequency in Hertz? We can use this equation whereby omega n is equals to 2 pi fn, and period of the system we can use this equation whereby f is equals to 1 over period. Okay, so let's look on how do we want to determine the fn, or the frequency, natural frequency in Hertz. Okay, so we know that omega n is equals to 2 pi fn. So fn is actually equals to omega n over 2 pi. Okay, so omega n is square root k over m. So use your calculator, find the fn. Okay, so we know that omega n is square root k over m. So square root k is 857.8 over mass, which is 49.2 times 10 to the power of minus 3. Okay, so sometimes student forget to put this one. Okay, so don't be careless, look at the question carefully. So you get omega n is equals to square root k over m, 132.04 radian per second. So if you divide this with 2 pi, you get 21.01 Hertz. So we already answered this question. Next, we want to determine the period of system. We know that fn is equal to 1 over period. So period is 1 over fn, 1 over 21.01 Hertz. So using your calculator, so we will get 0.048 seconds. So we have already determined these two. Okay, so try on your own and you can check the answer from here. Okay, alright, next let's look at example 2. Okay, so example 2, it asks you obtain the free response of this in the form of this. So what the question is trying to ask you is that it asks you to determine what is A1 and A2 and omega n. So it wants you to find what is the unknown. Okay, because why? It already gives you the initial condition. So x naught is equals to 0.05 and x dot naught is equals to negative 0.3. So we have looked on our previous lecture. To find A1, we can use the first initial condition, and to find A2, we can use the second initial condition. Okay, and how do we want to determine omega n? Omega n is actually square root k over m. But if you look at the question, it doesn't give you directly what is the k and m value. So how are you going to determine the natural frequency? Okay, actually the information is there, it's just that it doesn't give you directly. So how do you want to solve that? Look at this. Okay, do you know what does this represent? So if you look carefully, this is the equation of motion. So why it is important? Because we know that for free vibration, it is mx double dot plus kx equals to 0. Okay, so in order for us to find omega n, okay, we need to know what is the k and m, and the k and m value is given in the equation of motion, whereby m is equal to 2 and k is actually 128. So omega n is square root 128 over 2. Okay, so you can get what is the omega n. Okay, next what we need to do is that we need to use the initial condition to find A1 and A2. So to find A1, okay, we need to use the initial condition. So x naught equals to 0.05 is, sorry, before we do that, we need to we need to use the initial condition. So x naught or x naught is equals to A1 cos 0, because t is 0, so all of this has become 0, plus A2 sine 0. Okay, because t is 0, initial condition, so this, all of this will become 0, so this will become 0, therefore x naught is A1, because cos 0 is 1. Okay, so we know that A1 is x naught, so A1 is x naught, which is 0.05. Okay, that is when we use our first initial condition. Now, when we want to find A2, we need to differentiate this equation. Why? Because it is given in x dot naught. So x dot t is negative omega n A1 sine omega n t plus omega n A2 cos omega n t. Then what we need to do is that we apply the initial condition. So from this x dot naught, okay, or x dot when time is 0 is equals to negative omega n A1 sine omega n 0 plus omega n A2 cos omega n 0. Why 0? Because initial condition, meaning that the time is 0. So we know that sine 0 will become 0. So all of these will become 0, and cos 0 will become 1. So x dot naught is equals to omega n a2, and a2 is x dot naught over omega n. So when we apply the initial condition, we know that x dot naught is negative 0.3. So a2 is negative 0.3 over omega n. So omega n is 128 over 2. So square root 28 over 2. Get 8. So divide by 8. So become 0.0375. So now we have already determined what is the A2 and A1 value. Okay, so now what we need to do is that we replace what is A1 value in here and what is A2 value in here and what is the omega n value. So xt is equals to A1 which is 0.05 cos omega n. So omega n is 8 cos 8t plus A2. So A2 is negative 0.0375. So this will become negative 0.0375 sine omega n t, sine 8t. Okay, so this is the equation or the solution for this example. So if you look here, okay, the answer is the same. Alright, so let's see if we want to find, if let's say I extend this question, find x when time is equals to 8. So how are you going to solve that is that, so what you need to do, write back this equation, put this in your calculator, cos 8 multiply with 8, so t is equals to 8 minus 0.0375 sine 8 multiply with 8. Okay, so put it in your calculator and you can get the answer. Alright, so let's say if I extend the question, I change the question. Okay, find when, what is the displacement when time is equals to 3. So this equation, time, we replace it with 3, put in your calculator and you can get the answer. But please remember, in your calculator, make sure that the mode, when you do your calculation for vibration, make sure the mode is in radian, okay, not degree. Okay, so you can go to the calculator, okay, check your manuals how to change the mode. Make sure that every time when you do your calculation for vibration, it needs to be in radian mode, not degree. Okay, why we can't use degree? This is because we know that omega n, the unit is radian per second, and it is not degree per second. So that's why you must make sure that the unit in your calculator must be in rad, not degree. Okay, and the reason is because omega n is radian per second. Alright, that's all for this session. In our next session, we're going to look on free vibration of damped system. Thank you very much.